Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No. We've got a mixture here. Now, Amy is going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry. We'll be here next Wednesday night as well. So bring those questions with you if you want, and you could ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam, Praxis peeps, big shout out to you guys out there too. And especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out. And I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Everybody, welcome to Wednesday night math night. I always look forward to this time with all of you, purely because I absolutely love solving math problems, and I love helping you prepare for your exam. These exams are not easy. They're so hard, and that's why we're here today, because it is a passion of mine to help you out. So here we are, Wednesday nights, every night, 6 to 7 Eastern Standard Time, just solving math problems together. So before I get started, I always like to know who's in the room. So I always ask like a get to know you question. So it also helps guide our conversations for the night. So in the comment box, let me know where you're from, what test are you prepping for, and this is a good question. I always like to do a get to know you question. Do you like daylight savings time the way, do you like it when it is right now, or do you like it over the summer? Like, do you like having that extra hour in the morning of daylight, or do you like having that really long summer night? I personally love it right now. I love when we fall back, I think is what we did, and it gets light at 6:30 in the morning and it's dark right now. I don't know. It just means that the holidays are here. I am obsessed with this time frame. I don't know why. I just am. So which one do you like better? Hey, Melissa, I have a question about what we went over last week with the fundamental accounting. If there are specific choices that have a sub choice, do you add those? I am so sorry, but I am not so sure I know exactly what you mean by that question. So maybe clarify, or maybe email me an example of that. I don't know. I'm sorry. And long summer nights. Listen, I recognize I am not the majority here. So Houston, Texas. Hey, Chris, it is good to see you. Long summer nights. Like I said, I am well aware I am not the majority. My best friend loves it too. She was like, I don't understand why you love this so much. Like, it doesn't make sense to me. And I'm like, that's okay. It doesn't have to make sense. Opposites attract. If there are two sandwiches and they each have chips, fries, or a salad. So, like, trying to figure out if I have the choice of two sandwiches and the choice of fruit, chips, or salad, or like there's a specific fruit that goes with this sandwich and there's a specific chips that goes with this sandwich and specific salad that goes with this. Sorry, I am just trying to make sure I understand your question. That's all. So let's go ahead and get started. My computer, y'all, if you are new with us, welcome to this amazing math show where my amazing iPad likes to just disconnect. So let's see. They go with each sandwich. Okay. I will solve a problem. I am not good at coming up with those kinds of problems off the top of my head. So I will absolutely add that fundamental counting principle. Oh my gosh, you take it tomorrow. Well, I'll still do a problem like that because someone has a question about that. Melissa, find me on Facebook and I will answer your question tonight. Find me on Facebook. It's just going to take me a minute to find it. And we're like live right now. And so I can't, I can't go digging for a problem, but find me on Facebook and I will answer that question. 2 Sammys and then chips, fruit, and a salad. Okay. Joseph, I wish I could give you a big hug right now. My husband, I guarantee you, is like, why are you yelling? Big hug. There's my big hug. I am so happy you have been with us on this journey for so long. I always look forward to seeing you in our Wednesday night math sessions. That makes me so proud. That makes me so proud. I'm going to flash the world. You passed your test. Y'all, this is why we do what we do. This is why we do what we do. I am so happy for you. Okay. Now I'm going to be like so excited tonight. All right, Melissa, you've got this. You are going to pass tomorrow like Joseph just did. Huge congrats. That's awesome. Hi, Milagros. It is so good to see you. What are some examples for abstract and concrete numbers? I think because you've been around for a while, you hear me talking about concrete, pictorial, and abstract representation. Concrete and abstract numbers are not a thing, but concrete, pictorial, and abstract representation is absolutely a thing. So, little side note, and I will just add like a page here. Anybody taking a test that has teaching pedagogy, you have to understand how the progression works. So like if you're taking GK, they ain't going to ask you a question like this. But if you're taking out like math for elementary, math for middle, math for high school, and there is teaching pedagogy on here, you have to understand the progression. And that progression goes when we are introducing and teaching concepts: concrete, pictorial, or numerical. I think I spelled that wrong. Abstract. All this means is that when we're teaching a concept, we start with a concrete representation for students. And then, so we pull out those manipulatives and we are making math tangible for our students. Then we move into a picture representation for our students. And then we move into abstract representation. So a very simple example would be this. If I'm teaching my students how to add within 20, then I would pull out manipulatives and I would say, what is 5 plus 9? And if I ask students what 5 plus 9 is, we would start with 5 red counters and 9 yellow counters, and we would literally count them out. And then the picture or the numerical representation of that would be 5 and then 9. And then the abstract representation is using those symbols to write what we actually mean. So that said, I think that's what you're asking, Milagros, is how we teach and what direction we go when we're teaching. Now, what I don't want you to get in your head is that we go concrete, pictorial, abstract, and that's it. Like kindergarten teachers, you're concrete. First grade teachers, you're picture. Second grade teachers, you're abstract, and we're done. We're always sitting in abstract. That is not the case. This is a fluid model that we're constantly going in between because students are constantly learning new things. So as we introduce new concepts, we're going back to that concrete model. And then when they don't get it or they're struggling with that abstract representation, we're going back to that concrete model. We're constantly going back to that concrete model when we're trying to address misconceptions and stuff like that, or when we're addressing new concepts. So I think I answered your question, Milagros. That was like, just a little rabbit trail. I love it. All right, for those of you who are new, welcome. Welcome to Wednesday Night Math. We're going to get into our first problem now. So here we go. As part of a survey, 1,200 people were asked to name their favorite sport, where the table and the circle graph below present the results. Find the central angle for the portion of the circle graph representing baseball and football combined. So this question we actually did last week. We did the elementary version of this question last week, where it said, find the percentage of students who chose baseball and football combined. And remember, we talked about percentage being a part of a whole, and we talked about what that looks like. But when we're finding the central angle, we have now taken this problem and elevated it to my middle school and high school people, really more my high school people. So how do we find central angle? Well, central angle is this angle in the middle of the circle right here. These are central angles. So we're trying to find the central angle represented by the portion of baseball and football combined. So what is the angle measurement of baseball and football combined? So how are we going to solve this? Well, I need to figure out how many people chose baseball and football combined. So I'm going to look at my chart and I'm going to see that baseball is 132 and football is 312. So I'm going to do 132 plus 312 to at least figure out how many people that is. So 132 plus 312 is 444. Is that right? That seems kind of like a silly number. 444. Now, what is my process for figuring out that central angle? Well, I need to figure out what percent these people occupy of my results, because this chart is going to represent 100%. So if I can figure out the percentage, then I can figure out what my central angle is, because I know that 100% of the degrees in a circle is 360 degrees. So if I can figure out the percentage of football and baseball, I can just multiply that percentage times the number of degrees and figure it out. Now, for my elementary, middle school, my elementary people, this problem may be a little beyond your content limits, but you should be able to find percent of football and baseball people. So the only part you're not doing is multiplying that percent times 360. The rest of this is absolutely something that you would be doing. So I'm going to do 444 divided by 1,200. And that's going to give me 37%. So 37% of my people chose football and baseball, but that does not mean it's a 37-degree angle. I need to figure out what is 37% of 360. What is 37% of 360? How am I going to do that? What x is equals 37% transferred into a decimal, 0.37 of multiply 360. 133.2 degrees. So the answer is D. Pretty straightforward. Not hard at all. Questions? I forgot to mention, some of you were probably like, what is she writing all over here? If you have something that you want to see me go over in the upcoming weeks, please let me know in the comment box. I am not going to be here next week. We are going to take the week off for Thanksgiving, the Thanksgiving holiday. However, we will be back the following week. So if you have anything that you want to see me cover, please let me know in the comment box and I add it to my next week list. So I will add it to my upcoming weeks. All right, let's go on to number 2. Chris, this linear problem and then there's another linear problem are just for you. All right. What is the x coordinate of the point on the line drawn when y equals 6? What is the x coordinate of the point on the line drawn when y equals 6? So sorry, when y equals 6. All right, so I can look at this graph and I can think to myself, what is that going to be? The problem is the y coordinate is way up here. So we're looking for when y equals 6. And when y equals 6 is way up here. And this line isn't going to get there for a really long time. So I'm kind of in a stuck position because it's not going to get there for a while. So I can't just look at the graph and figure that out, right? So what do I need to do? Good question. I need to figure out the equation of this line and then plug in 6 for y. So how do I figure out an equation of a line? Good question. Equation of a line. I can do it 2 ways. I can do y equals mx plus b, or I can do y minus y1 equals n times x minus x1. I like y equals mx plus b if I have all my information. Y equals mx plus b is slope intercept form. And mathematicians are not creative. And so slope intercept form literally means that is going to give you your slope and your y-intercept, where m is your slope and b is your y-intercept. So I can visually see that my y-intercept is -2 because your y-intercept is where your graph crosses the y-axis, and your x-intercept is where the graph crosses the x-axis. So my y-intercept is going to be -2. And my slope is the only other thing I need to be able to gain an equation of a line. So how do I figure out my slope? Slope equals rise over run. So I'm going to find a point, which is already highlighted, and I'm going to find another point. So here's a point, here's a point, here's a point, and I'm going to count. I'm going to go rise over run to get from one point to the next point. So my rise is 1 and my run is 1, 2, 3. Rise is 1, run is 1, 2, 3. So 1/3 x minus 2 is the equation of my line. Now, what is the x coordinate when y equals 6? So what am I going to do? I'm literally going to plug in 6 for y and solve. Add 2 to both sides. 8 equals 1/3 x. How do I get x by itself? Well, a lot of people are going to say divide. And unfortunately, dividing is not going to work in this case. I have to think, what is being done to the x? It's being multiplied by 1/3. So I need to divide by 1/3. But when we divide by fractions, it makes it messy because then I have to do keep, change, flip. So what I'm actually going to do is multiply by 3/1. So x equals 24, which is A. Or no, C, sorry. I don't know why I said A. Questions? All right, let's move on to problem number 3. If a circle has a diameter of 8 centimeters, what is the area of a sector with an angle of 38 degrees? If a circle has a diameter of 8 centimeters, what is the area of the sector with an angle of 38 degrees? So let's go ahead and draw our picture. Remember, drawing a picture is going to be your best friend. So I'm going to draw a circle with a diameter of 8 centimeters. And there goes my iPad. Welcome to Wednesday Night Math Night. Still don't know why it does that. All right. So draw a circle. Drawing a picture is always going to be a good strategy, especially when we're dealing with geometry and we need to visualize that. In fact, I was talking to some of my teachers the other day and they were like, oh yeah, I should, blah, blah, blah. And I was like, listen, even to this day, I tutor lots of people. Even to this day, I still draw pictures. Still draw pictures no matter what. So draw that picture. I promise you it is going to benefit you. It's not going to hurt. All right, here we go. So I've got my circle with a diameter of 8 centimeters. What is the area? So I need to figure out, now this says area of a sector. All that means is a section with a central angle of 38 degrees, which means it's going to be an acute angle and it's going to be something to that effect, right? So how do I figure that out? Well, I need to figure out what the area of this entire circle is and then go from there. Can't do anything without the area of the entire circle. So area of a circle equals pi r squared. You'll notice that I put a little circle down there. That is purely for when I start doing composite shapes. So when they tell me to find the area of something like this, then I know when I'm solving it, area of my rectangle, and then I solve, and then area of my triangle, and then I solve, and then I can see the different pieces. That is totally just a notation, test taking strategy, planning, like tip of the day. So area of my circle equals pi r squared. What is r? R is my radius. What is a radius in a circle? The distance from the center to the outside. So this is a radius, this is a radius, this is a radius, this is a radius. A diameter is the distance from the outside of the circle to the outside of the circle and cuts through the center. So if my diameter is 8 centimeters, then my radius is going to equal what? 4 centimeters, because 4 plus 4 equals 8. So my radius is going to be 4 squared. The number one mistake people are going to make in this problem is they are going to put 8 there. And they're going to do 8 squared, even if they know that the radius is 4, because when we are rushing and we're under the pressure of a test, that is where we make our mistakes. So this is going to equal 4 times 4, because 4 squared equals 4 times 4. 4 times 4 is 16, and I am going to leave it in the notation with pi. I am not going to multiply by 3.14, only because when I look at my answer choices, I see that they all have times pi, so they did not utilize that notation either. So now what? Now what? Well, if I know that my whole circle is 16 pi, then half my circle is going to be what? My whole circle, all the yellow, is 16 pi. Then what is half of my circle going to be? 8 pi. 6.92 is kind of close to 8. So if I were in a rush and I needed to pick an answer fast, and this is all I could get, I would choose between A and B. Why? Because these are really close to 8 pi, which is the value of half the circle. And 38 degrees is not close to half. Keep in mind, a circle has 360 degrees, which means a half a circle is 180 degrees, which makes sense because a straight line is 180 degrees. So if a straight line is 180 degrees and I'm looking for 38 degrees, this teeny tiny section right here, then I know these are probably, using my reasonableness, not going to be the right answer. But let's go ahead and figure out how to find area of a sector if we didn't have, the opportunity for elimination. So how do I figure that out? Well, I need to figure out what percent 38 is of 360 so that I can multiply it by 16. So what percent of 360 degrees is 38 degrees? So let's transfer that into words. What? X. That's what I'm looking for. What percent of multiply 360 is equals 38. How do I get X by itself? Do the opposite of multiplication. Division. That makes sense because remember, percent is a part out of a whole. This is my part. This is my whole. So that's how I'm figuring that out. I'm going to use my handy dandy calculator. 38 divided by 360 is 10.55%. In the calculator, it was 0.1055, but what I did was shifted that decimal place 2 places to the right. But really, I probably shouldn't have shifted that decimal place because now I just need to multiply 16 times 0.1055 to get my answer. Why am I not doing 16 pi? Because the pi is just going to stay a pi. So all I have to do is multiply it times the 16, and I get 1.688, which rounds up to 1.69 pi, which is A. Any further questions about that? All righty, let's keep going. The art teacher surveyed 135 first graders and asked them what their favorite color was. She constructed the following pie chart. How many more students preferred pink than red, orange, and purple combined? How many more students preferred pink than red, orange, and purple combined? All right, so here's our pie chart, and the pie chart gives us percentages. The pie chart does not give us numbers. So we have to figure out the numbers based on the total that we have. So the art teacher surveyed 135. There's my total. First graders. And the question is asking how many more students preferred pink than red, orange, and purple combined. That how many more question tells me that there are more students who prefer pink than red, orange, and purple all together, which makes sense because red, orange, and purple is this section right here, and pink is this whole section right here. So there are more pink than red, orange, and purple combined, which means I need to add those together. But I need to figure out how many students that is. So I'm going to take the 135 and multiply it by the percentages that they've given, but the decimal form of those percentages. So how do I convert a percent into a decimal? Move the decimal 2 places left. If there is no decimal, then we plop an imaginary decimal at the end of the number and then move it 2 places to the left. So this 44.1% becomes 0.4410, right? So that's how we do that. Now, I'm going to multiply 135 times all of the percents that are relevant to this problem. So does that mean I'm going to do the percent with the blue? No, they didn't ask for blue. So I'm not going to waste my time calculating a percentage for a section that doesn't matter. So 135 times 0.06, 135 times 0.058, 135 times 0.066, but not for blue. And now I'm going to use my calculator to solve. A 135 times 0.441, that equals 59.5. It says round to the nearest whole, so that becomes 60. 135 times 0.06, 8.1, which is 8. 135 times 0.058, 7.8, which also is 8. Or 135 times 0.066, which is 8.91, which rounds up to 9. So now, when I do this, I'm going to take pink, 60. Excuse me. And subtract the combined total of 8 plus 8 plus 9. And 8 plus 8 plus 9 equals 25. So 60 minus 25 equals 35, which is C. And we just disconnected again. So let's reconnect. Woo! Excuse me, I am so sorry. Got the sneezes today. It's reconnecting right now. Ooh, now I've got it like in my nose. All right, share screen. All right, let's rock and roll, y'all. All right, so the answer is C. There we go. Ta-da! All right, the next problem is a teaching pedagogy problem for my K through 3 people or my K through 6. This is one of those problems. You either know it or you don't. So let's read it together. Mr. Johnson is doing an activity to introduce his lesson. He shows students a dot card like the one below for a couple of seconds, and then asks students how many dots they saw. What skill is Mr. Johnson most likely working on using this activity? Counting, subitizing, addition, or cardinality? So, this is something that you either know or you don't. And I'm telling you, your life will be easier if you, I just dropped my pen. I'm telling you, your life will be easier if you just know it. This is subitizing all day. Why? Here's why. Because subitizing is the student's ability to basically find patterns quickly and see patterns in these dot cards. Really, what we're trying to get students to do is recognize that this is 2 without counting it. It's going to make their life so much easier. And that this is 4 without counting it. And so by looking at this dot card right here, students might see it in a variety of ways. Students might see 4 plus 2, 2, 2, 2. Students might see it as 8, 2, 2, because they know that this is 4 and this is 4. There's a variety of ways that students are going to find that pattern, but helping students find that pattern quickly is subitizing. It's not counting. Why is it not counting? Because he showed it to them for a couple of seconds. Students aren't going to be able to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 in a couple of seconds. Counting is a very important strategy. However, it's not what this teacher is working on. It's also not addition. Can students use addition through the process of subitizing? Yes, but that's not what they're working on. When you see dot cards, you think subitizing all day long. All right, sound good? That's like a done, quick problem. All right, somebody in here asked for sequencing and nth numbers in the pattern. Here we go. All right, Cassandra is working on a pattern. She is given that the third number in the sequence is 14, and the sixth number in the sequence is 26. What is the 24th number in this sequence? All right, so I'm going to give you like a earth-shattering news flash here. My earth-shattering news flash is that you really don't need to know arithmetic sequence and geometric sequence formulas 90% of the time. You really don't need to know arithmetic sequences most of the time. And in fact, I am actually looking up the formula because I don't think I ever used it on a test. Nth term in a sequence formula. I'm going to give it to you because some people want it, but I'm going to show you how I do it without that. So the nth term in an arithmetic sequence, and I'll explain the difference in a minute, is A sub n equals A sub 1 plus n minus 1 times d, where d is the difference, the common difference. N is the term you're looking for, and A sub 1 is the first term. Yes, Melissa. Thank you, thank you, thank you. Now, you may need the formula. I don't know what your questions look like, but I'm telling you, when I took the test a while ago, like years ago, I don't like formulas. Like, I don't like holding formulas in my brain. So here's what I would do. She's told that the third number is 14. So 1, 2, 3, 4, 5, and the sixth number is 26. What is the 24th number, right? So here's what I would do. I would figure out what is the gap between the 14 and the 26. 26 minus 14 equals 12. That means I have 12 between the two. I am going to divide the 12 by 3 because I have 1, 2, 3 hops that 12 needs to share with. And that equals 4. That means I'm adding 4, adding 4, adding 4. 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. Now, how do I figure out the 24th item in this pattern? I literally every single time would sit and go 26, 27, 28, 29, 30, 31, 32, 33, 34. That is the 1, 2, 3, 4, 5, 6, 7, 8th term in the sequence. So I'm going to keep tally. 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50. And this is how I did it on every test. Is it the most time efficient strategy? No. But I don't like holding formulas in my personal brain. Here's the other way you can do it, because now the state of Florida lets you use a calculator if you're taking a K through 6 test. And if you're not taking a K through 6 test and you're taking a 4 through 8 or a 6 through 12 test, you already get a calculator. So I'm going to do 14 plus 4 equals, and I'm going to sit here. 26 is the 6th term. I'm trying to make sure you can see my calculator. So that's number 6. So watch what I'm going to do. That's number 6. I'm going to sit and go 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. And I might do it again to make sure I didn't make an error. So 26 plus 4, that's 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Did it twice. I got 98. Now, how do you do it with the formula? Because some of you are like, I just need to know how to use the formula. I'm trying to find the 24th term in the sequence, which is A sub n, equals. You don't get a calculator in TExES? What test are you taking? Are you taking K through 6? No, this is not K through 6. If you've done sequences, that would not be on K through 6. What test are you taking that you don't get a calculator? Whew! That is crazy. Hi, John. It's good to see you. Equals A sub 1. And you're like, wait, they didn't give me the first term in the sequence. You're right. But I figured out the common difference by doing 14 minus 26, or 26 minus 14, and then divided it. So the common difference is 4. So box plus n, I'm trying to find the 24th term, and the common difference is 4, right? Oh, you are taking elementary. I am shocked that sequences is on the EC6. That's crazy. The state of Florida just announced that we are allowed to use calculators. So it is literally like within the last month, it's a brand new thing. All right. But if I know I'm adding 4 for everyone, I can subtract 4 to figure out my first term, which is 6. So now I'm going to do 24 minus 1 is 23. 23 times 4 is 92. And 92 plus 6 equals 98. That's how you use the formula. Pretty straightforward if you have all of the pieces and parts to the formula, right? All right. We have time for one more, and then I'm going to turn it back over to Dr. A. If you think of anything you want me to go over in the next couple of weeks, please let me know in the comment box, and I will absolutely add it. It shows you pattern boxes as picture images. So yours looks something like this. Right? And then they're saying, now this is not an arithmetic or a geometric sequence because you're not adding the same amount to every one, but that's what they're looking for. Okay, so that is not arithmetic, nor is it geometric because you're not adding the same amount, or actually this would be 3. So I added 2 here. I added 3 here. I added 5 here. Like, it's not the same amount. If it's arithmetic or geometric, you can use that formula. If not, you just have to find the pattern and sit and work with it, is really the best strategy I can give you. All right, the line represented by the equation 4x plus 3y equals 9 is graphed on an xy coordinate plane. What is the equation of the line perpendicular to the original line that passes through -8, 4? So here's what I need you to know. Perpendicular slopes are negative reciprocals. And this is standard form, which is not helpful at all because it doesn't give us any useful information. So I literally have to take this, put it into slope intercept form, which is y equals mx plus b, so I can find that slope. So I need to get the y by itself, which means I'm going to subtract 4x from both sides. 3y equals -4x plus 9. Why -4x? Because I want to keep my x term in the front. Then I'm going to divide everything by 3 and get y equals -4/3 x plus 3. That tells me that my slope of my perpendicular line is going to be flipped and negated. So that means this is my original line. My slope of my perpendicular line is going to be +3/4. So I can plug in y equals slope x plus b. Did they give us our b? No, but they gave us a point. They gave us x comma y. So I can plug that in. 4 equals 3/4 x, not x, -8 plus b. The 4 and the 8 cancel out. So I have 4 equals -6 plus b. Add 6 to both sides. B equals 10. So y equals 3/4 x plus 10. Now all I have to do is get it into standard form, because that is what that's what all of my answer choices are in, is standard form. So I'm going to put it into standard form while I reconnect my iPad, because my iPad likes to disconnect. Thinking, 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 thinking. Yes, sirree. Sorry, can you tell I have a toddler? We sing everything. Y'all, I just got my holiday pictures back, and it is good. I just got our holiday pictures back, and I am so excited. Like, our holiday pictures, they're so cute. And I'm obsessed with Christmas cards. So if you want a Christmas card, find me on Instagram. I'm going to post a link that you can put your little address in. And if you want a holiday card from my family, you can have one. You can put your little address in, and it'll be so cute, because I'm obsessed with holiday cards. So you are not going to want to miss out on that. Let me just tell you. All right, moving on. Find me on Instagram, AmySync_. Where was I? Oh, here. So now I'm going to subtract the 3/4 x. So I have negative 3/4 x plus y equals 10. However, I can't have a negative or a fraction in the first term. So I have to multiply by -4 to get rid of this 4 on the bottom. So that becomes a positive 3x, a minus 4y, and I already see that my answer is going to be A. All righty, we are out of time for today. I am going to pass it over to Dr. A. If you have any questions about things that you want to see in the upcoming weeks, let me know in the comment box. I am happy to add them into the next week. We are not together next week, but in 2 weeks, I will add them. Enjoy the time off with your family, whether you celebrate Thanksgiving or not, and I will see you in 2 weeks. Have an amazing week, y'all.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions, and I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you use the coupon code, all capital letters, SINK35, that's SINK 35. That will take off 35% off any of our prep courses on our website at the Learning Liaisons. It doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions, because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well, and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today, and hopefully we'll see you next week too. Talk to you soon.